Hello, this is Tolbert, Chapter 2, Lesson 1. You've probably heard of the old trick question, which is heavier, a pound of bricks or pound of feathers or pound of bricks? Now, lots of time people say bricks, but why do the bricks actually seem like they're heavier? Let's take a look at it for a moment. Imagine on the right side of the balance, you're going to place a pound of bricks. How much space would that take up? And on the other side, we place a pound of feathers. How much space would that take up? If you did that, it looked like the pound of feathers would take up a whole lot more space. But, as we all know, a pound is a pound. So the biggest difference between a pound of bricks and a pound of feathers is the space that each of them occupy. Mass describes the amount of matter in an object. The SI unit for mass is the kilogram, kg. We also know that as 2.2 pounds in English. The kilogram is typically too large of a unit for us to convert, so we tend to use just the gram as our main base unit in metric. It's actually 1,000th of a kilogram, which means it takes 1,000 grams to make up 1 kilogram. Matter is anything that has mass and takes up space. All matter has mass. In this particular example, the steel, plastic, rubber, glass are the different kinds of matter. If you're looking at the car as opposed to the bike, the car simply has more stuff that makes it up. So it takes up more space. It's got the engine, it's got everything else, the stereo, the seats. We tend to use the term mass and weight interchangeably, but they are not the same. Mass is the amount of matter in an object, whereas weight is a measure of the pulling force of gravity on an object's. A 2.3 kilogram bag of flour has the mass of 2.3 kilograms, no matter where it is in the universe. On the moon, on the planet Earth, it's going to have the same amount of universe. However, the weight of the bag of flour is less on the moon. The weight changes because the location changes. Standing on the moon is smaller than the Earth, so that changes the weight. But the amount of stuff that makes up the 2.3 kilogram bag of flour, if you don't take any flour out of that bag, it should be the same everywhere it is. You need to write this down. This is important. Venn diagram between mass and weight. Each of them are a property of matter. Each can be measured, and here's that equation in the middle for what they are measured out to be. You need to know that the SI unit for for mass is the kilogram, and the English unit is the slug. The SI unit for weight is the newton, and the English unit is the pound. If an object has more mass, it also has more matter. Mass has an English unit known as the slug. The kilogram is the basic SI unit for mass. Mass is consistent, but weight can change based on location. Weight is the same measure of the pulling force of gravity on an object. SI unit for weight is the newton. You can convert your weight in English units to metric by simply multiplying it by 4.4 newtons. So take your weight in pounds, multiply that by 4.4, and that will tell you what your weight is in newtons. Here's an example of our solar system. Notice the mass stays the same whether you be on the Earth, the Moon, Jupiter, or the Sun. But the weight changes. I start off being 140 pounds, but by the time I step on the surface of the Sun, I am 3,900 pounds. Volume is the amount of space an object takes up. The fundamental unit in volume is the cubic meter. A more convenient, smaller unit is the centimeters. The measure of volume of liquid is easy. Pour the liquid into a graduated cylinder and read the meniscus at eye level. To measure something solid, why it's cubed centimeters, is length times width times height. By measuring length times width times height, you will always get the volume right. Or you can do what's known as water displacement. An object displaces the same amount of water as it is that is equal to its volume. Thank you.